Evening. This is Group 24, and we are here to present on the topic multi-stage turbine. The multi-stage turbine. This is a picture of the multi-stage turbine. Moving on, we're going to talk about the introduction to multi-stage turbine. And multi-stage turbines are used in power plants and propulsion systems to efficiently extract energy from steam or gases. By using simple multiple stages, they gradually expand the working fluid to maximize energy extraction while minimizing losses. So basically, multi-stage turbines. So multi-stage turbines are used to extract energy. They are used basically in power plants and industries, dams, and because of its large scale, it has a high efficiency. And we have some key components of multi-stage turbines, which include the casing, mm, razor blades, stator blades, and lots of stuff. So we'll be playing a video which will be showing this key component of a multi-stage, and the video is flowing. So this is the video and playing the video.
The major components of a steam turbine include the major components of a steam turbine include a casing, which contains the steam and provides support to the rotor. The turbine rotor, which holds the moving blades that convert the kinetic energy contained in the steam to rotating mechanical energy. The fixed and moving blades, which convert the kinetic energy to mechanical energy. Diaphragms that hold the fixed turbine blades. Journal bearings, which maintain the radial alignment of the rotor. A thrust bearing to maintain the axial alignment of the rotor. Shaft seals to contain the steam in the casing and keep any air out of the condensing unit. An inlet valve or valves to control the flow of steam to the turbine. And a speed regulating device.
So the video was showing us the various parts of a multi-stage turbine, the various parts of multi-stage turbines, and you have plenty various from the blade, the diaphragm, the compressors, the hollows, the inlet valves, and the outlet valves. We're going to talk about how it operates, and starting with how it operates. A high velocity fluid enters the inlet valve, and it enters through a nozzle. So as it enters, it gains velocity, and as it gains velocity, the pressure decreases. It is going with its high speed, high pressure. So when it enters, the velocity that will act on it will be very high. It will increase. If the velocity increases, the pressure will decrease. So going to the next one, that's the blades. As we heard, you have the rator's blade, you have the stator blade. The rator blade is used for energy extraction. Yes, the rator blade is used for energy extraction. And as I said earlier on, the multi-stage turbines, it is efficiency, it extracts more energy. So the rator blade is responsible for that. So it's the rator blade will extract energy, then the energy will be converted to kinetic energy. The kinetic energy will be transferred to the blade when it will start to rotate, generating rotational motion, which is potential or frictional motion. Yes, next one is the stages. We have a lot of stages. We have three stages. We have the first stage, second stage, and the final stage. The first stage talks about when the fluid is entering with a high pressure. And the second stage talks about how the blades will rotate, extracting energy, gaining more energy. And the final one talks about how The high pressure velocity fluid that entered will be leaving with a low pressure fluid. To be leaving with a low pressure, when it leaves with a low pressure, it means all the energy has been extracted. So basically, the multi-stage turbines is used for energy. We use it to extract energy, and it minimizes losses. The more it increases energy, it minimizes losses. That's the reason why we are using turbines. So this video is a summary of how the multi-stage turbine works, how it operates. So I'm going to play the video.
This turbine consists of 4 individual turbine units, 1 high pressure, 1 intermediate pressure, and 2 low pressure units rigidly coupled to each other.
Am I supposed to be explaining the video?